Welcome dear students. We continue the topic transportation. In the last lecture, we have told you two methods of finding initial basic feasible solution. First was northwest corner rule. Second was lowest cost entry method. Now we will explain you the third method or Vogel's approximation method, VAM. V means vogels, A approximation, M for methods. In this method, we make allocations on the basis of opportunities called penalties. In this method, we will proceed with the following steps. Step first, we write the difference of smallest and the second smallest costs. It is called penalties. In each row to the right of the corresponding row and write the similar penalties of each column below the corresponding column. So, in step first, we will find the penalties of each row and each column. Penalties are found by subtracting by the difference between the smallest cost and the next smallest cost of each row, and similar way in each column. Step second, select the row or column for which the penalty is the largest, means maximum, and allocate the maximum possible amount to the cell with lowest cost in the particular row or column. We will proceed in the column or row which has maximum penalty and allocate maximum in the cell which has lowest cost. If the largest penalty among the rows and columns is not unique, if the two columns or two rows or one column, one row have the largest penalty repeated, in that case, select the row or column which can allocate more amount in the lowest cost cell of the row or column. Note this thing. If the penalties are equal, then we select the row and column in which the allocation is maximum in the lowest cost cell. This is the second step. Now we comes in third step, adjusting the supply and demand units in the respected row and column through the cell in which allocation is made, and cross or leave the row or column in which the supply or demand is exhausted, means completed. Step 4, repeat the step first, second and third with the cost in the remaining rows and columns left after crossing the exhausted row or column in the previous step till all the supply and demands are exhausted. Now, what are the advantages of this method? In this method, we proceed to avoid as many penalties are possible, so the basic feasible solution obtained by Vogel's approximation method is very close to the optimal solution. Second case, what is the disadvantage of this method? In this method, more time is consumed to compute the initial basic feasible solution. Means it takes so much time in finding the initial basic feasible solution in compared to northwest corner rule or lowest cost entry method. Now we will explain this with a suitable example. Suppose we have given a transportation problem where these are the sources. 4 sources are given, F1, F2, F3, F4, and 3 destinations are given, W1, W2, W3. So cost matrix is a 4 by 3 matrix, and cost of transportation of unit material from ith source to jth column is Cij is fit or given here. Now we have to find out the initial basic feasible solution of this problem by Vogel's approximation method. So we will start from the step first. First we will find out the penalties of each row and each column as follows. See the first row here, the minimum element or the smallest element is 2 and the next smallest element is 4, so its penalty is 2. In the second row, lowest element is 1 and next lowest element is cost is 3, so its penalty is also 2. In third row, lowest cost is 4 and the next lowest cost is 5, so its penalty is 1. In the fourth row, lowest cost is 1 and the next lowest cost is 2, so its penalties is 1. So these are the penalties of 4 rows. Here the supply AI is given 5, 8, 7, 4, and in the columns demands are given 7, 9 and 80. Now we will find the penalties of each column. Here see in the first column lowest cost is 1 and next lowest cost is 2, so its penalty is 1 here. In the next column lowest cost is 3, next lowest cost is 4, so its penalty is 1 written here. And in the third column lowest cost is 1 and next lowest cost is 2, so its penalty is 1 written here. Now we see all the penalties of rows and columns. Clearly maximum penalty is 2, but it present in the 2 places in first row and second row. So we see the first row and the second row. First row lowest cost is 2 and we can allocate 7 here. 7, not 7 but only 5 here. But in the second row lowest cost is 1. So lowest cost in both rows is 1 and we can allocate here 8. So allocation is also greater than in place of the place 2. In first place the allocation is possible only 5, but in the second row and third column allocation maximum possible allocation is 8. So we will allocate 8 here. Now in adjusting we will subtract the row supply 8 minus 8 is 0. So second row will be crossed. Second row will be crossed. And next step, we will not write the second row. Similarly, in column, the demand is of 18 and we have already allocated 8. So subtract 18 minus 8, it will remain 10. This was the first allocation process. There is no doubt, all of you. So we will go in the next step similarly, and in writing the next step, we will cross or not use or leave the second row. In next step, we will write first row, third row, fourth row, first column, second column, third column, and form a matrix. Then again, we will find the penalties of each row and columns in the similar. And repeat the process first, second and third continuously till all the columns or all the rows are adjusted or supply and demand of the transportation problem is adjusted, and in last we will find that, see here we are seeing you that second row is left. Again, penalty of first row is 2, penalty of second row is 1, penalty of third row is 1, penalty of first column is 1, penalty of second column is 2, and penalty of third column is also 2. So penalty, maximum penalty is also repeating in this place. Maximum penalty is 2 and it appears in front of first row, second column and third column. Now we will see that in the first column minimum cost is 2 and we can allocate 5. We can allocate 5. And the second column here penalty is maximum, minimum cost is 4 and we can maximum allocate 7. And in third column again, please pay attention here. The minimum cost is 2 and we can allocate 10. So in these three, when the penalties are same, we will use that we will allocate at that place where the cost is minimum and allocation is maximum. So we will allocate in the fourth row or left in the left matrix, third row and third column 10. Then clearly in third row supply will become 14 minus 10 4 and demand 10 minus 10 is 0. So now the third column is adjusted. So now in the next step we will left the third column. Then in next step, the remaining matrices, rows are F1, F3 and F4, columns are W1 and W2. And again we find the penalty from first row, penalty is 5, from second row, penalty is 1, from third row, penalty is 5. And in first column penalty is 1 and in the second column penalty is 2. So we will again seeing that penalty is repeating again in the first row and third row. Now in first row minimum element is 2 and we can allocate only 5 here. And in the third row minimum is 1 and we can allocate 4 here. So we will allocate at that point where the cost is minimum. So we will allocate in the column first 4. Now allocating 4, the fourth row or in the remaining matrix third row, its supply becomes 4 minus 4 is equal to 0. So in the next step, F4 will be crossed or leave or deleted, and the penalty in the first column will remain 7 minus 4 is equal to 3. Leaving the third row, we reach where the matrix is 2 by 2. Now again find the penalty. Penalty in the first row 5, second row 1, first column 3, second column 3. Penalty, maximum penalty is 5, and appearing here the minimum cost is 2. We can allocate here only 3. So next in the first column, next step to adjusting the supply, we allocate in the second column 2, and after allocating 2 in the second column, we will go through and allocate 7 in the second row and the second column. Then all supply and demands are completed. So final solution of this by this vogel's approximation method, the allocations in the cell C11 is 3, C12 is 2, C23 is 8, C32 7, and C414 and C43 is 10, and finding the cost by this method is find by multiplying and summing the cost and allocation. We get the minimum cost is 3 into 2 plus 2 into 7 plus 8 into 1 plus 7 into 4 plus 4 into 1 plus 10 into 2, and it comes out to be rupees 80. Thus we have find the solution of this transportation problem by Vogel's approximation method. It is a very important method, and generally we use this method for solving or for finding the initial basic feasible solution of the transportation problem. Now in the next lecture we will explain you the Modi method for finding the optimal solution of a transportation problem. Thank you. Practice this method in many problems to be easy, and then we will explain the Modi method for finding the optimal solution. Thank you very much.